Sekejap, I tengok yang berapa orang dah sampai. Sekejap. Sekejap, masih lagi ada yang masuk. Okay, let's wait for another 1 minute. Okay, let's start. So what we have, actually we stop at this topic. So we were going to continue today. So here, as what we can see, there is an exercise on part of water treatment. Then you can see a lot of calculation. Then some of it you can see there is a issues whereby you can relate that is on the water treatment system. Okay. Okay, is clear? Dengar? I change the system here. Dengar tak?
Dengar dia.
Dengar. Okay, sekejap. Okay, sekejap. I pula yang terkejut. Sekejap. Okay, Alhamdulillah. So, last week I macam go through very fast on this topic sebab nak tengok on the calculation, right? So here, sekejap. Okay, here you can see that there, this is what we will learn in our topic. So in ECW 567, so we focus a lot on this part, right? And also not to forget the wastewater treatment part. So these two parts is very important in ECW 567. So by knowing that we have water intake from the stream, so how the treatment looks like, okay? So there is a difference, treatment of water in the stream and also from the well, right? Then definitely it will, we need to know the function of a treatment. Okay, hari tu kan, bila I stop, so you have, we have 2 hours kan. Yang ni you dah, I dah masuk kan. I stop dekat mana? Calculation dia. Can someone tell, inform me? I had 2 class. Lupa. I stop dekat mana? I go through very fast kan on this. Betul tak?
Betul dia.
So I tak, okay, tak apa. Kita ni je. Right, thank you for ni. Okay, tak apa. So, okay, daripada mana sumber air tu? It's from the stream, from the reservoir and also from the well. So you need to know where the sources come from. From there, only then you know how to treat the water and what kind of the process. So bila kita kata process, this is where you can see here. Right? Okay, I will go very fast but benda ni you akan tengok balik. So this is the what we will learn, and also on the distribution system. This part on distribution system, okay. Then distribution too will go to some to the industry, and some will be to the homes. So after we use the water, so the water will become wastewater. Then we need to know how to treat the wastewater, and then we will see that how's the system that bring all the wastewater into the treatment plant. So that's why you will see the combined system and separated system is mentioned here. So combined system will combine the water that comes from the storm and also from the domestic sanitary sewer from this line. So both will combine and goes to the treatment plant. So if separated system means that it will only focus on the sanitary sewer for the treatment, and mostly on the storm sewer will go directly to the river. So that's we call a separated storm sewer. So on the group discussion, so here you will notice that you will not see any of the term what we call here is activated sludge. Yeah? We will not see here because it's actually activated sludge in water treatment is only for wastewater treatment. Yeah, activated sludge because in sludge we have a microbe that we need that microbe to digest the organic matter in wastewater. We're not going to see this term in this water treatment, tak ada. So in water treatment, tak ada activated sludge. So you can go through and see whether you can find activated sludge in this slide. Slide ni memang tak ada, right? Okay. So that's why we start here. So you can see the flow of our treatment. We have to know where the sources of water come from. So we have to know whether it comes from the groundwater, it comes from the wells, perigi, telaga, and also surface water like rivers, lakes, and reservoir, and also can come from rainwater. Rainwater, you collect the water at the open area, whereby masa ambil rainwater tu is a clean and unpolluted water. Dia tidak terdedah kepada pencemaran, and sometimes we have a storage on top of the building to store the rainwater. So ketiga-tiga sumber air ini is depending on the country selection. So which water sources of water from that area, you can see the abundance of water on that area. So normally in Malaysia we have a lot of surface water. That's why our water intake is come from the rivers. Kalau daripada lake pun boleh, tapi daripada lake ni kadang-kadang dianya adalah datang daripada lake yang dulunya adalah mining, sumber perombongan. So lakes ni sometimes you have to need a further treatment. That's what you can see in the other slide. So this is the comparison between groundwater, surface water and rainwater. Okay, this one you have an overview. So what's the difference between groundwater, surface water and rainwater? Groundwater ni lebih kita kata selamat berada di bawah tanah, dan surface water ni lebih mudah. Dia punya composition tu variable sebab ianya terdedah, and rainwater ni you can also can see that the composition dia can be variable, but dia tidaklah seperti surface water, but still is a very kita kata dia punya composition tu masih lagi mudah untuk dia berubah, dia punya variation of the composition. So here when we look at the water quality, we always describe in terms of water quality as physical, chemical, microbiological and radiological. This is the term that you use in books, we use in any journals, or when we are in engineering society, and normally we use this term. We use the same term actually. And the terms that describe what you can see, what you can feel, and what you can actually use your kita kata diri by to look at the water and to give what we can measure. So normally it called a physical. Kita panggil physical sebab kita boleh nampak, bau dan rasa, dah pegang. Dan and sometimes the physical ni kita boleh melihatkan kepada color, turbidity, temperature, taste and the smell. So the physical ni normally is what we can what we use to look and also to taste it and also to hold it. Okay? And the chemical and what you can see and hard and soft waters that you see in the laundering activities, whereby kalau hard water dia tidak mudah, campuran air dan sabun itu tidak mudah menjadi bubbles. So bila tak jadi bubbles, dia tak akan menjalankan fungsi menyucikan pakaian. Sebab bubbles tu sebenarnya is the power of the soap itself, you need the bubbles so that it can clean up your laundry. Yeah. So that's on the chemical, we will describe it as hard and soft waters, and then microbiological, and what we describe the water in terms of the health, and it's refer to the virus and bacteria. And radiological is where you can see the water have radiation from the nearby nuclear industry and so forth. So that's a water quality that we use to describe. Yeah? This is the term that we use. So physical, okay, kita tahu turbidity, kadar kekeruhan. If you take a glass of water, then you can look up at the light. So kalau boleh tengok the glass, kalau tengok the pandangan di belakang gelas itu nampak, means that the turbidity level itu kurang. So that you can see that on the other side, nanti kita panggil turbidity. Turbidity itu adalah presence of suspended material such as clay, silk, and fine divided organic material. Sometimes they also have a plankton inside them, and we call it as turbidity unit. And in water, normally it's less than 5, 5 turbidity unit. And then the color, you can see the color is come from the organic material that come from any vegetation, and sometimes also can come from inorganic matter like a sand, silt, so on. And of course does not affect the health, but no, the color itself it's not normal to us to use it as a drinking water. Selalunya drinking water kita adalah colorless, right? And then the taste and the smell, where it comes actually from the organic matter itself, yang tu yang trigger pada rasa dan bau. And sometimes it's from the inorganic salt, daripada minerals, daripada batu dan pasir. It's a natural minerals we call inorganic salt, dissolved gases dan sebagainya. And of course we will not have it in our water. And then temperature is within 10 to 15. And of course kalau lah ianya terlampau panas pun, sometimes kalau it doesn't preference on the individual, so normally is within 10 to 15. Chemical, when we talk about chemical, selalu is fluoride that we use in the Colgate, and the iron. This of the mineral listed here is the natural mineral. Sometimes it comes from the soil and sand nearby, and that's why it's in the water. And what actually bother to us, kalau ianya mengganggu, kalau ianya go beyond the range, allowable range, kalau dia go beyond besar dan kuantiti dia besar, contohnya macam arsenic, that what we have in Bangladesh, di mana sources of water dia mengandungi banyak arsenic. So arsenic is harmful to girls. So what we tak nak ianya berlaku. So we have to check our water. Definitely before kita ambil air untuk bergunaan, memang kita check the quality of water and also to check this content. And other than that, like nitrate, then DCN, so ammonia is come from the the food waste nearby sometimes. So we have an industry that produce a lot of chemicals, and then it might go to our water sources. And so also like nitrate is come from the pesticide and also come from the fertilizer from the plants. And also as you can see here, kalau toxic organic substance juga sometimes it come from the pesticide, and anticide dan sebagainya. And all those amount, kalau dia melebihi pada apa yang dibenarkan, definitely the concern is it affect the health of the human. Okay, microbiological is where kita lihat kepada virus, bakteria, protozoa, the worms. This is the kita measure dia dalam family because they have lot of types in water, and normally we call it as the group. Yeah, and for microorganism in water, we have this test estimate the number of microorganism whereby it called the coliform group. Or E. coli. So these two parameter that we will measure in the water. So kalau boleh, memang kalau bukan kalau boleh saja, but every test you have to look for the amount of the E. coli and coliform inside the water, so that is safe to be used. It has to be free. It has to be free. It's very important that we check this in the water. Bahaya. And then when we talk about radiological, it comes from nuclear industries whereby the water itself is exposed to the high radioactivity and it's not normal. So it's easily penetrate into the water because of the molecule in the water is H2O, and that is easily uh, attached to any radiation. Yeah? So that's if we have a nuclear industry nearby, definitely we have to check on the radiological characteristic of the water. All right, so let's proceed. Yep. Okay. Right. On the water quality standard, we have the standard we call a raw and drinking water in Malaysia. So this is how it looks like. We have what we use in standard we call a raw water. So this is the list of parameter that we have to check. So in terms of by looking at the water quality, this guideline, so everyone have to follow. If you want to use the water, means that you need to measure the parameters, this parameter, so that it's within the range. And you can see, for example, total coliform here, the MPN unit is 5,000. Kalau tengok compare to um, the treated water, after the water is been treated, you can see the total coliform is absent at all. So they kena free from this water. So sama juga the parameter you can see in the group 1, group 2. So all here has to look through and measure, and then up to the sometimes on the parts that we call the very harmful chemicals like mercury, arsenic, and also the chlorine content by the chemical that described on what the chlorine in the water. Also we will check in the water, and also if there are any like the harmful like chloridine and so on. So those is listed here for us to use as a guideline. Kalau kita treat water means that we have to check all those components. So it's not that easy task for the engineers. So that's why we need a lot of engineers outside there. And you can also try to look at other quality standard in other country, and you have to look at where the sources of water come from. Only then you can compare what we have in Malaysia. So many of the country in in Europe and overseas, so they have the water intake come from the wells and the groundwater. So definitely the treatment tu lebih agak sedikit berbeza. Okay, when we talk about treatment system, okay, yang ni yang kita punya main core of this course is a treatment system. So potable water, potable water dia kata ni adalah potable water. So potable water ni adalah air yang kita manusia gunakan, either for drinking or other purpose. We call it as a potable water. Term dia adalah potable water. So kalau from from groundwater, normally is uncontaminated, but somehow it can influenced by any man-made spills into the ground, from the ground, masuk ke dalam sumber air, and then of course it will pollute the groundwater. So because the groundwater itself is deep down, from the ground, kita panggil ada satu kawasan di dalam ground itu yang kita panggil aquifer layer. Aquifer layer kat situ yang ada kita nampak ada air, sources of water kat situ yang dia akan flow upper from the upper level of ground hingga ke low level. So dia akan move sampai masuk ke dalam sungai. That is groundwater. So groundwater daripada surface of the ground tu it take very certain depth lah, very high lah dia punya ketinggian itu untuk sampai kepada sumber air. But somehow still boleh terdedah kepada man-made or any spills into the water, dekat groundwater itu. And surface water is easily dia terbuka terdedah, and then it might have an unpleasant characteristic. Okay, and then and then when we talk about the treatment system, kalau nampak the term ni selalu digunakan is disinfection is to kill all the virus. Filter plant to we need a filter plant to filter the water from the suspended materials, and also if we use a groundwater, so we need a softening plant. So yang ni term-term yang you akan nampak dalam proses satu always there is a disinfection. And for filter plants adalah untuk surface water, and softening plant for groundwater. So that's why you can see here, dia tulis kat sini, filtration plant for treat surface water, and softening plant is for groundwater, to remove hardness. So as you can see here in this treatment, okay. So kalau nampak sini, nampak tak disinfection? Nampak tak? Nampak tak? Huda, nampak tak? Proses disinfection. Nampak tak? Nampak tak Huda?
Nampak.
Dia proses ni dekat mana? Dekat awal ke dekat akhir? Huda, dekat awal ke dekat akhir? Disinfection. Daripada proses tu. Huda, nampak tak? Awal ke akhir?
Kat akhir.
Kan, kat akhir before the storage. Kan? So proses itu nampak ianya dekat yang tempat yang terakhir. Tempat yang terakhir itulah sebelum pergi kepada storage. So benda ni dia dah go through all those treatment, dah pergi go through all those treatment, then lastly you will have this process disinfection untuk membunuh semua kuman. Then only then you goes to the distribution system. So storage tu ada satu tempat lah untuk pergi kepada distribution system. Okay. Nama dia kat sini, kalau this diagram, nama dia adalah flow diagram of a conventional surface water treatment plant, and then it has a filtration plant dekat situ. So filtration plant, as you can see, ada process what we call a rapid sand filter there, so that it will remove all the suspended materials. That's why it's suitable to be used for surface water treatment. Okay. So all this is the process. Step process tu akan ada dia punya teori and also the calculation. This is what we will learn in this topic. Adanya teori dan akan adanya kiraan. Okay. Alright. Okay. So here kan daripada sini kita tengok Okay, daripada sini kita akan tengok bahawa cuba tengok ni. Apa beza antara treatment yang di atas dengan water treatment di sini? Apa beza dia? Apa beza dia? Okay, apa beza dia kat sini? So this is the treatment for water softening plant. So we have treatment for groundwater. Kalau nampak ni, the primary objective is to remove hardness. Hardness ni groundwater. Hardness is the minerals. So dalam air banyak minerals yang come from calcium and magnesium. So kat sini you will have this object yang ada proses recarbonation. Kita akan nampak recarbonation dekat treatment surface water treatment. Tak ada kan? Tak ada kan? Betul tak? Tak ada tak? Ada tak? Akram, ada tak? Akram ke nama? Sekejap, tengok nama.
Ada.
Ada. Dalam treatment ni, ada tak recarbonation, Akram? Ada tak?
Macam tak ada je.
Macam tak adalah sebab ianya tak sesuai. Sebab ianya adalah ni treatment untuk surface water. Kalau treatment untuk groundwater, dia kena ada recarbonation sebab dia nak remove. Apa proses recarbonation? Adalah untuk remove hardness. Recarbonation ni adalah proses to adjust the ionic condition, iaitu to avoid any corrosion in pipes or any deposition from calcium carbonate before and after lime soda ash process. So this is where recarbonation ni adalah introduce carbon dioxide into water, whereby this lime soda ash process ini is one of the water yang kat bawah ni, water softener system. So dalam proses ni dia akan ada before dia akan ada lime soda ash process, whereby lime soda ash process adalah is a water softener system. Dia nak softkan air tersebut. So dalam proses recarbonation itu akan ada calcium hydroxide and soda ash used as a reagent, and this process is a soluble magnesium and calcium salt are removed as calcium carbonate, and magnesium hydroxide will be precipitate. Benda tu akan timbul dan ianya kita akan remove. After this remove of precipitate, we will obtain a soft water. So proses ni berlaku dekat recarbonation, di mana ianya akan menggunakan reagent. Reagent tu adalah calcium hydroxide and soda ash to soften the water. And then kalau nampak disinfection masih lagi perlu ada sebab ianya perlu untuk membunuh segala bakteria dan kuman. So disinfection masih ada, is the last process. We need wrapping sand filter. We need this settling tank. Sludge will be produced sebab ini sludge ni datang daripada all those suspended materials. And this is rapid mix, and this is reaction basin, just to mix between the chemical and also with the water. And then the only difference that we have this process recarbonation to remove hardness in the water. So that's the main purpose. Okay. Nampak beza Nampak Alright. So kalau datang daripada air yang kita kata selain pada air sungai dan air from the groundwater, come from lake. So lake ni adalah kawasan yang dia tadahan air. Tadahan air tu tidak going in and out from this lake. So dia adalah satu kawasan tadahan yang berhad, dan sometimes the lake adalah kawasan yang di mana dulu adanya aktiviti mining, pelombongan, and that's why you need a certain process. On top of the normal process, kita akan ada activated carbon kat sini, kita akan ada potassium permanganate kat sini, and then sometimes we need the lime to remove the hardness, and sometimes also we add this polysulfate. So it's depending what the water, the quality of water from the lake itself. So here, apakah function activated carbon tersebut? This is the function of activated carbon tersebut. Used by water treatment plant for taste and to control the smell and to ensure that the removal of organic chemicals and materials menggunakan this coconut shell and wood carbonous material to digunakan untuk menarik this organic matter, any removal this organic, dia akan menarik dan dia akan attach kepada this carbon, sumber carbon tersebut, iaitu from the wood and from the shells and from the coconut shells ataupun daripada sumber coal, arang batu. So this will use to menarik, dia akan attract those the organic matter to this this carbon material. So dia akan jadi absorb, dia akan jadi, dia bukan AB, dia akan AD, absorbent. Kita activate the carbon material, kita activate the carbon untuk menarik this organic matter. So this is to reduce the smell. And then the potassium permanganate, why it being used is an oxidant used in the water to control the smell, to remove the manganese, iron and color from the water, and also to control biological growth that trigger all those in the water. And then yang lime tu macam tadi, yes, lime caustic soda is to remove the hardness, because sometimes the lake ni dia banyak terdedah dengan kawasan pelumbungan dan sebagainya. Sometimes they have these minerals inside the water. And then the last one is polysulfate, is to prevent the red, the iron and also the black color from the manganese. Then is to reduce the soluble lead and copper in the potable water. That's why you can see a certain process in those add on into the process. Kalau normal process yang tadi you nampak macam surface water, kalau groundwater you add this recarbonation, and from the lake you have more process. Because sometimes the lake itu tidak satu sumber air yang tidak bergerak. Sometimes it come from the previous mining activities, and then that's why sometimes you can see that this lake also contain minerals. Ada soalan ke? Ada soalan ke?
Setakat ni tak ada lagi doktor.
Okay, bagus. Okay. Then primary objective, kalau pakai ni dia akan start gatal sikit pakai headset ni. So primary objective is to remove suspended materials, the turbidity and color, and also to eliminate pathogenic organism. These two, Okay, boleh semua orang minum air yang sama daripada sumber air yang sama. Kita mengambil air daripada pipe water, and then definitely pipe water is clean, it's colorless, and also is safe to drink. So that's the main purpose kan, kita boleh relate apa yang kita gunakan air itu dengan what will be the primary objective. So one is to remove the suspended materials, turbidity and color, so that we have a clean and colorless water. And second one is safe to drink. So we eliminate all those pathogenic organisms. And the treatment that we use always the concept of what we call coagulation and flocculation. So coagulation yang kita belajar, yang ni yang bila kita tengok pada proses. Tengok sini dulu. Ingat coagulation. Ambil pensel, ambil pen, tulis coagulation proses. Ambil and then lagi satu tangan, ambil notes ni. Missing and flocculation. Tulis sekarang. Missing and flocculation. I want to show it to you. Tadi missing and flocculation, then coagulation, right? Let's look on this treatment. Ada nampak coagulation tak? Ada nampak coagulation tak? Tak ada? Okey, tak ada ya? Okey, coagulation tak ada. Rapid mix ada? Flocculation basin ada? Kan? Ada dua ni. Dua ni kita nak belajar dulu. Rapid mix dan flocculation basin. Ingat. So, proses yang pertama adalah rapid mix. Proses yang kedua adalah flocculation basin. Okay, before that you nampak it's written here where's the water sources come from. Daripada air sungai, ya. And then come from the river or the lake, ya. So dia akan melalui screen to remove all those rubbish, the rag, whatever. The screen ni patut menghalang sampah-sampah yang besar masuk ke dalam proses. And then these two is our first main topic, rapid mix and flocculation basin. Okey, kata tadi tak nampak coagulation, betul? Sekejap. Kita tak nampak coagulation ya. Okey, kita tak nampak coagulation. Okey. Kita start dengan coagulation process. Okay, we start with coagulation process. So coagulation process is where is a process di mana surface water intake ni dia mengandungi color, mengandungi turbidity and they have this bacteria. Sebab bakteria ni pun ada dalam air dalam bentuk suspended material juga macam ada dia suspended yang ada di dalam air. So ada turbidity, color and bacteria. That's why you need this process what we call an coagulation. Tak ada dalam ditunjukkan sebab coagulation ni adalah chemicals yang kita gunakan, chemicals yang tak bahaya. Dan coagulation ni akan disambut dengan proses flocculation. So dalam proses flocculation akan adanya coagulant. Coagulant ni adalah chemical yang digunakan untuk treat suspended metal. Okay. Di mana proses ini it will turn the small particles of color, turbidity and bacteria into the larger flocks. Itu adalah apakah proses coagulation process? Coagulation adalah untuk air, small particles di dalam air itu yang menyebabkan color and turbidity and bacteria ini bergabung dan menjadikan ianya flock yang besar. Larger flocks. So small particles tu dia akan jadi flocks. So bila dia jadi flocks dia akan mudah untuk kita remove dalam sedimentation basin sebab dia akan dibawa keluar dan juga dia akan suspended, dia akan juga tenggelam di dalam air. Dia akan going down because of the weight. Dia akan dekat base tu dia akan turun dan juga kita akan remove dia sebagai sludge. Okay. So coagulation is applied to remove the colloidal particles. However, the terms have been used like we use removal of dissolved iron. Then why is called an iron? Sebab kita tengok next slide. So coagulation is the method to alter the colloid, the small particles tu tadi, colloid, so that they will be able to approach and adhere to each other to form a larger flock particles. So dia akan bergabung dan melekat dan menjadikan larger flocks particles. So this is what you can see here. So this is the colloidal particle. Sebelum dia bergabung, you can see it's negative charge around them. They are very stable. And they will not attach to each other because both are negative charge. So bila kita introduce positive ion, so we will add a chemical that have lot of positive ion into the water. So it will reduce the surface charge of the colloidal particles and the colloid will not against each other. So they will come and attach and form a bigger flock. Ini nama dia adalah flock. And you can see the positive ion in the water when we introduce the coagulant. So coagulant ini adalah yang mempunyai tiga kaki positif sebab kita nak banyak positif. So we choose a chemical that have lot of positive, and when the colloids be introduced with the coagulant, ianya akan menjadi precipitate. Ini adalah precipitate. Ini adalah akan jadi particles yang besar, and somehow when we relax with water, kita masih dapat H2O yang tinggi. So bila dia masuk dalam air, the chemical reaction will akan mengasingkan the particles, akan jadi flock, and you can see the H2O, the molecule that we get is higher, is 14 molecule of H2O. So this is whereby you can see the aluminium where it goes into the water. So the aluminium with 3+, and also we can also use the ferric iron. This is also safe, non-toxic, and you can see dia punya ion itu melebihi daripada dia banyaklah positif ion. Okay. So ni faham konsep coagulant? Faham tak? Konsep coagulant. Boleh? So we will do the exercise yang petang, yang late evening tu 5 to 6 ya. And then here kita tengok pada teori, terpaksa tengok pada teori. Okay. And mixing, okay, dah masuk coagulant, dah masuk chemicals, we need a technique what we call a rapid mix. So kita akan mulakan proses itu dengan rapid mixing. Rapid mix, so this is the process where the chemicals are quickly and uniformly dispersed in the water, because we need those chemicals react in the water. So that's why we have a rapid mix. And then after rapid mix, we have what we call flocculation. Flocculation ni adalah is a slow and gentle mixing technique. Okay. So during coagulation, the chemical reaction will take place. In the rapid mixing, to form a precipitate. Dia akan membentuk precipitate ni, kita nampak butiran particles yang lebih besar, is a flocks. The precipitate is formed, must be brought into contact with one another. So they will form a bigger large particles, we call it flocks. And this is what we call a flocculation. So but the process still continue with the gentle mixing. So rapid mix kejap saja, and then you spend more time on the gentle mixing. So that's the process of mixing and flocculation. Okay, patah balik tengok proses. So you only look at this process. Faham? Boleh? Nampak? Ada soalan? Ada soalan? Hafizi ada soalan? Saya bayangkan gambar you all ni dengan di sebalik sana kan, pakai spek. Pakai spek lagi Hafizi?
Pakai.
Pakai, okey. Power banyak ah?
Tak adalah banyak sangat.
Ya ke? Tak apalah. Dia tapi all the time you have to wear?
Ya.
Tak apalah, nanti esok dah banyak duit, buatlah lasik ya.
Tak ada.
Tak ada kan? So yang ada kat situ apa? Proses apa? Yang tadi kita belajar proses apa?
Dekat mana itu?
Kita belajar tadi ada dua proses. Dua proses tadi kita belajar tadi kat bawah. Dekat slide ni, dekat proses ni, flow diagram ni, proses apa yang kita belajar tadi? Nama dia proses apa?
Disinfection ke?
Ya ke? Hafizi tidur lah ni. Siapa boleh tolong Hafizi? Iman Ilham. Proses apa yang kita belajar tadi? Jenuh apa I cakap-cakap tadi. Iman Ilham. Proses apa tadi Iman? Lepas tu coagulation tak ada kat sini, tapi coagulation kita belajar. Lepas tu kita belajar apa? Mesin. Okey, bagus Iman. Kita belajar, Hafizi, kita belajar rapid mix dan population basin. Rapid mix is a fast moving technique. It's a mixing, fast moving technique untuk mengacau coagulant, untuk mengacau chemicals. Is what we call rapid mix. Dan this population basin is where the slow mixing technique berlaku dekat population basin. So one is rapid mix and one is population basin. Kita baru belajar dekat these two process. Okay. So tengok balik slide. Saya buka balik slide. So Hafizi tengok sini. So kita belajar. This is the chemical that we will use. We call our coagulant. So chemical dia nama apa? So panggil Anis Syatira lah. Anis. Coagulant tadi nama apa Anis? Ingat tak? Coagulant tadi nama apa? Anis Syatira. Anis.
Yeah.
Coagulant tadi nama apa? Coagulant. Chemical yang kita gunakan tadi nama apa?
Chemical.
Apa yang kita gunakan dalam air? Untuk proses coagulant. Chemical apa yang kita gunakan?
Aluminium
Lagi?
dengan
Atau dia atau
atau ferric sulfate.
okey. Sebab apa ianya digunakan agak-agaknya? Kenapa? Apa kebaikan disalum ataupun ferric sulfate itu digunakan? Kenapa agak-agaknya? Pada pendapat Hanis.
Sebab dia ada ion positif.
Ion positif, ya. Okey, dia ion positif. Sebab apa kita perlukan ion positif? Okey, orang tanya orang lain pula. Thank you Hanis. So siapa yang tak pernah panggil? Luqman. Luqman ni bijak pandai ni. Luqman Muhammad Zainal. Okey, kenapa agaknya kita kena introduce banyak positif di dalam air? Kenapa agaknya? Luqman mana tak? Luqman Muhammad Zainal. Kenapa agaknya? Kenapa agaknya kita kena introduce banyak positif ion dalam air? Kenapa agaknya? Luqman. Muhammad Luqman. Luqman.
Maybe dia nak buang banyak charge
Banyak apa?
negatif. Nak buang
Charge negatif. Negatif tu datang pada mana?
daripada colloidal particles.
Kolot itu daripada mana? Bahasa biasa. Kolot itu bahasa mana? Bahasa lain selain kolot. Inilah small particles lah. Kolot itu adalah small particles. Kolot itu adalah small particles. Okay, Luqman pandai. Okay, megat pula, megat. Ni megat ni selalu nama-nama orang yang dia fighter lah. Fighter dalam game. Main game tak megat?
Main.
Main ya. Okay, small particles tu kenapa dalam air tu? Mana datangnya small particles ni dalam air? Apa yang menyebabkan adanya small particles ni dalam air? Macam mana Megat tahu bahawa air tu dia ada small particles? Jawapan dekat slide tu, Megat.
Yang mana?
Carilah. Saya dah buka slide lah. Jawapan kat situ. Cepatlah, Megat. Macam mana? Mula-mula kan kita ambil air daripada sungai kan. So kita tahu, nampak je tengok air ni, dia ada small particle dalam sungai. So mana datang small particles dalam sungai tu? Mana dekat situ ada small particles of ...
Yang color, turbidity,
Color, turbidity and
bakteria.
bakteria. Color ni kan, kalau tengok air sungai tu, color air sungai tu sama ke dengan color yang air kita minum? Sama tak Megat?
Lain-lain.
Lain kan, tak sama. The color tu yang ada color dalam air tu sebabkan small particles yang ada dalam air itu menyebabkan air itu berubah in term of color. Kan juga turbidity juga, kadar kekeruhan tu is due to the small particles. And also not to forget the bacteria. Bacteria ni pun ada size. So that's why it considered as a small particles. Dia ada size. So all those kita kena remove. So remove one of those dalam first process itu adalah kita menggunakan teknik coagulation process. That's the first technique, the easiest technique that we use and the cheapest one. So we just introduce this coagulant, masukkan yang banyak positif chemical, yang banyak positif ion, so that it helps all the small particles ni akan menjadi flock yang lebih berat dan lebih mudah untuk dikeluarkan. It will settle down at the bottom of the basin, dia akan settle down dekat sedimentation basin, dia akan jatuh ke bawah because of the weight, and you will remove the particles. You can separate particles dengan air. So air will continue moving on the flow surface. Dekat bawah tu it will collect a lot of materials, the suspended materials. So that is our objective. Okay. Right. So kalau kenapa dipanggil removal of dissolved iron? Kenapa dipanggil removal of dissolved iron? Then let me call names. Yeah. Ashraf, Muhammad Ashraf. Selalu Ashraf ni jawab. Ashraf.
Ya saya doktor.
Ashraf ni bagus, selalu dia menjawab. Did you always dalam gambar ni macam very smart? Selalu ke smart datang ke kelas? Smart lah kan? Have to. Smart di luar? Smart berjalan-jalan di luar? Smart tak?
Tak pasti doktor.
Kena engineer kena smart lah kan. Okay. Semua orang bersetuju ni, semua orang banyak. Ashraf disukai ramai. Okay Ashraf, so my question is, kenapa kita panggil proses ni juga adalah proses removal of dissolved iron? Kenapa? Agak-agak.
Sebab
Supaya you have the ideas. Kenapa? Removal dissolved iron. Why? Tu dah buka slide tu. Cuma kena baca je. Baca dan mengolah menggunakan ayat sendiri. Apa? Sebab apa? Nampak tak? Colloidal particles dan particulate matters tu. Kenapa agaknya? Kita tengok kat slide depan ni. Dia tak payah slide lain, slide depan ni je. Slide depan you. Agaknya Ashraf? Did you say anything? Tak dengar. Ada cakap apa-apa tak? I think something wrong with the mic, right? Okay, Ashraf terkeluar. So because it called as a dissolved ion because of this, because that's the suspended material itself dalam particles tu dia memang ada negative charge. So that's why it called, we want to remove this dissolved ion. So that's the process. Itu saja. Dia tak ada complicated process. It's a simplified and is safe, and also the chemical is cheap to purchase. So benda tu macam it's something is in front and easily to find in the treatment. Itu kita punya purpose juga, kita kena fikir. Okay, then you have this calculation we call velocity gradient. Velocity gradient because bila kita mengacau air tu bila so we have a chemical, betul kita nak kacau air. So this the chemical of course it will control by we need this power input. Then the degree of the mixing we will look at the velocity gradient. Sebab velocity the velocity we know the flow, and we have this gradient from the flow itself taking part daripada lower part to the from the upper part to the lower part. That's why we call it as a velocity gradient G. And then of course dia akan ada geseran bersama particles dan air, either shear taking place. So the higher of the G, so the more violent will be the mixing because you make it the velocity is very high. So of course lagi kuat lah mixing tu. And the function of the power input is the unit of volume of the water, and this is the formula. This is what we use dalam proses mixing. This is a formula that only we use in this process. Ingat ni. So this is the only you can see in this topic. Yang topik untuk velocity gradient ni untuk flocculation and also rapid mix. So G is the velocity gradient or 1/2. Then power input, volume of the water in the mixing tank, and of course you need to know what type of the water by looking at the dynamic viscosity. And then the number of particle collision, so the particles that will collide, lepas tu dia akan bergabung menjadi satu flock yang besar is equal to GT, where T is the time taken for the process. And the rapid mix yang ni kita akan gunakan chemical reaction is completed within 0.1 second. So we have tank vertical ataupun inline or static mixer. Semua konsep dia adalah untuk memastikan air itu mix with the chemicals, and the time taken is 2 to 5 minutes. So here you can see ni nanti kita tengok balik. So here is a rapid mix tank. We have this pedal, pengacau dia pedal, and this is where we have chemical. The function is to add the chemical to water. So ada juga typical inline blender. So we have a straight, satu line, satu aliran. Then we have a propellers here untuk mengacau air, but the water will coming in and out in one direction. And then we have a chemical feed dekat sini into the water, and then we have this propeller to do the mixing. Kalau tak nak macam tu, you can also have a static mixer. So the water will go up and down due to the line that we design. Is we call a static mixer. It's a flow twisting technique. Masa dia bergerak itu dia akan bergabung dengan chemicals. And then this is what we need in our design, is to know the volume of the tank. So normally the tank is less than 8 meter cube. This is the guideline. And then we can have to choose either it's a radial flow or axial flow, because proses dia untuk pastikan air mix dengan chemical. So we can have this radial or axial flow, is depending on the selection. And then some of the tank kita ada buffer di tengah-tengah, di mana kita ada compartment berbentuk macam bilik, ada 2 compartment. And then we will look at the specific time for the process. And vertical buffer, why we need the buffer is to protect sebab dia adalah rapid mix. So kita tak nak any vortex, any circulation flow yang berbentuk vortex pusing. So that's why we have this vertical buffer to reduce the impact of vortex. And this is the geometry that we use in our calculation, is to check whether our design for the tank and also the impeller itself is suitable according to the allowable range. This is what we check in our exercise. That's also you can see in our exercise. So either when you choose this axial, then this is the range. If we choose the axial, kena pilih salah satu. And then kalau nak axial, then you have this sort of form allowable range for the axial. If you choose the radial, then you have sort of form of allowable range. Yeah. So this is a radial flow turbine impeller. This is how it looks like. Okay. And then this is the axial flow impeller. But the most interesting thing is, okay, this is where no, okay, this is where, yeah, this is where, okay, this is where you can see the flow. Kalau kat sini is a radial flow. So you can see the missing of the radial flow. You can see those missing on the radial flow. So radial flow ni lebih concentrated, and then is focus on the missing, all the parts, yeah, and it's more concentrated. Then this is the kalau axial flow, the rotation of the flow is much more higher. Then dia go, up and down on the higher direction of the flow. Those both radial flow, axial flow ni lebih banyak digunakan masa slow mixing technique dekat percolation tank. So kalau rapid mix, we want to have this radial flow sebab dia lebih concentrated, dia lebih mixing itu dengan chemical tu akan berlaku pada semua bahagian. So that's the purpose why we choose it. The pattern of the flow is by looking at the impeller, it will help us to focus on what is the process. Okay, ni sama juga compartment. Compartment, this is vertical compartment. Dia macam ada dua bilik. First, we have this impeller, then second we have another impeller. So this is some in process we have at least two compartment. Yes, the mixing will do it at both sides, and the flow of the water will flow from one side to the other side. So lebih efektif lah the process. Yang ni yang untuk mengelakkan vortex. Also sometimes we have this horizontal compartment. Yeah, it's depending on the process juga and type of water that coming into our tank, yeah, for the process. Okay, this is a flocculation. Yeah, this is flocculation. So the objective of flocculation is to bring the particles into contact so that they will stick together and form a bigger size. And then you need to control the velocity gradient G, and typical detention time is about 20 minutes, lebih lama. Okay, it's lebih lama sebab dia adalah slow mixing technique. Dia tak kacau bilau. It's a slow mixing technique. So you have the time taken tu lebih lama compared to rapid mix. Rapid mix is only a certain minutes. Tengok balik rapid mix berapa minit. Tengok balik kat sini. Rapid mix. So rapid mix here, so antara 2 hingga 5 minit rapid mix sebab nak kacau dia. Kacau kuat. 2 to 5 minutes. Jangan dia lama sangat. But for flocculation technique, you can have that. You can have it slower, perlahan sedikit. Then dia perlahan. The mixing is slow, mixing technique, and its time taken is 20 minutes. Okay. So flocculation normally is an axial flow impeller sebab chemical itu telah blend into the water, and then that's why we need an axial flow impeller yang di atas bawah up and down, a paddle flocculator, and also buffer chamber, buffer compartment. And then axial flow impeller are recommended over other type, and flocculator basin sometimes divided into 3 compartment. Lagi banyak compartment sebab kita nak pastikan ianya all those particles tu akan berhubung sesama lain and become a bigger flock. That's why you give a chance until up to 3 compartment. Sebab function dia untuk pastikan bahawa particles ini bergabung and form a bigger flock. Okay. Any other question? And then for power, we need a power input. So this is the impeller because we attach it with the impeller, pengacau itu. And is the rotational speed, then impeller diameter, and of course, because it will blend into the water, so then we need to consider the density of the liquid. Okay. And other of the Also we calculate the drag force of the pedals, but drag force ni ada geseran antara air dan juga the pedals. Then that's why we have to consider the CD, coefficient of the drag of the pedal, and then what actually happened in the water. Right, this is only an information you can look through the outflow solid context. And then did you do this exercise? Buat tak exercise ni? Buat tak? Tengok tak? Tak tengok lah raya kan. Belum raya, puasa. Okay, tengok tak tengok? Oh, puasa, penat puasa kan? Alah, penat puasa. Okay, Rabiatul Aldawiyah, cuba buat tak exercise ni? Buat tak?
Tak buat doktor.
Tak buat, tak apa, tak buat tak apa. Tapi faham tak? Cuba baca example tu. Kita tengok sekarang. Tapi nanti you all buat balik. Tak apa, cakap je. I okay je. Biasalah dekat-dekat exam baru buat kan. Then that's normal. Okay. So don't worry. Bagi tahu je. Okay. Example 6.11. Cuba baca. Siapa nak baca? Siapa yang tak tidur lagi? Alice Aziz. Orang Singapura ke? Alice Aziz. Dia Malaysian lah, of course dia Malaysian lah. Kau ada sangkut paut dengan ni. Alice Aziz. Hari tu last week boy panggil Alice Aziz ni pun tak menyahut. Alice. I think he live in Singapore, right? That's why dia didn't answer me. Last week pun dia tak answer. Alice. Muhammad Alice. Alice, di manakah? Siapa duduk rumah dia? Dia tak ada. Okay, nasib baik. Tak boleh on mic. Okay, tak boleh suruh baca. Okay, tak apa. Kenapa? What's wrong with your mic? Tak apa, tak ada masalah. Okay, as long as you are there, Farhan ni selalu left, turn left, turn in. Okay, so tak ada masalah. So, okay, Alice, I know you are there, tak ada masalah. Saya panggil orang lain. Megat dah panggil. Maisarah dah panggil ke? Maisarah Zulkarnain.
Ya, madam.
Okay, cuba baca example ni.
A city is planning the installation of a new water treatment plant to supply a growing population. There will be only one rapid mix basin and the flow will be evenly split between two flocculator drains, each with 3 basins equal in volume. The required water depth of all basins is 4 meter. Determine correct basin volumes, basin dimensions, tank equivalent diameter, required input power, impeller diameter from table below, and rotational speed using the following parameters.
Okay, betul. Okay, so dia bagi. So this is is a practice for all of you. Nanti soalan test, soalan final test. So dia soalan dia macam ni. Dia akan bagi senario dan dia akan bagi satu city atau satu area whereby dia ada masalah dekat situ. So masalah dia apa kat sini? Dia nak suruh bahawa dia akan ada permintaan untuk ada new plant, tapi dia hanya menghendaki satu rapid mix basin. Satu rapid mix basin. Kita tengok balik proses. Ingat lah, tulis dulu, tulis mana-mana. Satu rapid mix basin, then the flow will be evenly split into 2 flocculator train, and then the 3 basin will in each of the train will have 3 basin equals in volume. Okay, tulis dulu. I nak pergi pada proses. Okay, okay. 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 So dia tengok dia macam ni. Okay, apa dia nak? Dia nak adalah satu rapid mix basin. Dia akan ada satu rapid mix basin. Okay, this is rapid mix RM. Cantik RM. Okay, jap. RM rapid mix rapid mix RM here. Rapid mix the basin. So we have this rapid basin. Okay. And then from the rapid mix basin, dia akan ada air akan keluar. So dia akan divide into two train. Two train ni macam line lah. Dia akan two train. So each of the train akan ada 3 population basin. Okay, faham? Boleh? 3. Okay, faham? Rapid mix. So dia akan keluar dekat train, dia ada 2 train. And it will go to 3 basin, equal volume. So lukisan I tak equal. Okay, faham? So kita hanya belajar dekat sini. So those exercise with these 2 process. Okay. Right? Okay, faham? So siapa yang tak faham dia punya lukisan tu? So rapid mix. This is the rapid mix RM. Right? This is the rapid mix RM. And then it will flow with 2 train. Yeah. With 3 basin. Okay. Alright. Okay. Ada soalan kat sini? Nampak? Okay, clear? Boleh? Okay, then kita ada water depth for all the basin is 4 meter. Ini diberi. Then what they ask you to have a basin volume, basin dimension, tank equal diameter, required power input, impeller diameter of the table below, and rotational speed. So all this information is given. And you can see here rapid mix will take 2 minutes for the process. And then we have rapid mix the G velocity gradient. Then for collectors we have 3 of the velocity gradient sebab dia ada daripada ketinggian yang tinggi kepada rendah dan seterusnya paling rendah. So the population will take the process about 30 minutes. Ada 3 flow, 70, 50 dan 30 sebab dia dah semakin turunnya slow, much more slower. Water temperature is 5 degree. So yang ni kita boleh tengok information at 5 degree tu, information on the dynamic viscosity based on 5 degree, 5 temperature, 5 temperature Celsius of water. Boleh tengok dia punya karakteristik. And the place impeller at 1/3 of the water depth. So we have here, so this is the impeller. So that is divided into ni water depth. Then dalam ni kita divided into 3 section, 1, 2, 3. And then this dekat sini adalah yang kita namakan sebagai 1/3, place 1/3 of the water depth. Okay, daripada bawah. And then this is the radial and this is the axial type of the impeller. So we have the diameter shown here and then the power of the number and P. So first we will solve the question by a rapid mix design sebab ada 2 kat sini. Satu rapid mix, satu population. And we design the rapid mix first. Okay, kita kira, kita convert. So you can see slowly dia nampakkan kekiraan ini. And then daripada convert the meter cube per minute is a Q. And then volume, kita kira volume. Q times T, kita tahu proses tu adalah 2 minute, you get the volume. Because the basin have a equal size. And you divide the 16 with the water depth 4 meter and you get the area of 4 meter square. Senang je kan? Okay, itu cara dia. and then they have this equal length and width, then you square root kan dia, you get 2 meter. The TE ni I nak terangkan, TE cuba tengok TE ni, it's a geometric ratios of the impeller. So because kita akan ada basin, then we have this impeller. So impeller will do the rotation, will do the moving in the water, dia akan berputar. So putaran ini tidak akan melebihi daripada size of the basin. It has to be within 2 meters supaya it will go to reach end and also to end of the tank. So you can see here the value is 2 meter and it's accepted because our tank is 2 meter in terms of the length. Yeah, and the width also 2 meter. You can see the circulation of the flow. They reach hujung ke hujung. So means that it's good to have that geometric ratios of the impeller. Then we check that, and then we check the P, Pg squared mu, the volume, and then you get this in terms of the watt, berapa power input. Then from there, kan cuba tengok kat sini power input. Lepas tu kita pilih ini adalah rapid mix, that's why kita pilih radial impeller diameter, and then kita check satu-satu, and this is where the B, calculation of the B. So please check whether you get this value. Okay. So I stop kat sini. Okay, I stop dekat sini. Please this as a homework please everyone. Besok I akan sambung exercise ni. Boleh? Boleh, so I panggil lagi. Okay, I panggil all the names. Boleh?
Boleh doktor.
Okay, bagus lah. Okay, baik-baik. Bagus-bagus. Okay, jangan buka puasa lagi, still have time. So please go and do whatever that you want. So in preparation of buka puasa nanti. So I will see you tomorrow at 5 to 6 insyaAllah. Okay, anything else from all of you? Ada apa-apa ke? Ada apa-apa ke? Ada apa-apa?
Tak ada doktor.
Yeah, I see you tomorrow.
Doktor, attendance ada dekat U-Future ke?
Ada dekat U-Future ada. Tapi U-Future down hari ni memang ada slide, memang ada kat U-Future.
Sebab tak keluar dekat U-Future saya.
Tak keluar dekat U-Future you. Nama saya tak ada.
Untuk kenapa attendance tak ada?
I tengok tapi sepatutnya ada lah. You memang group ni kan. Sepatutnya ada lah. Tapi nanti I bagi jugalah kat dalam WhatsApp sekarang juga I bagi. Okay, supaya nanti adalah buat latihan kan. Okay, I bagi sekarang. Okay, kalau tak ada apa-apa, I will see you tomorrow insyaAllah. Assalamualaikum.
Waalaikumsalam. Thank you.
Salam, thank you.
Bye.
Thank you Rozah.
Bye.
Thank you,
Assalamualaikum.
Doktor.